Now, you're in your forensic atmosphere. You have a computer here that is owned by the adversary. If you shut down that machine, can you get back into the machine later on? Well, they got a username and password on it, so probably not. But you can do one of two routines against that machine because it is there and open and available at this point. You could go in and dig into the registry keys, or you could, if you're handed the machine and it's already shut down and they say, here, take a look at this, break into this thing, you could expose the username and password in a variety of ways. The forensic way to do this is to take the registry off of the machine, the registry file off of the machine, and examine it. What you're looking for inside of that ntuser.dat file is the hash value of the password that's stored locally on the machine. This will not work for like Active Directory if you're authenticating somewhere else. This is only for your local system. You can't use the Active Directory database. That's not going to work. So what you do is you extract the local SAM, and that's what you're shooting for. You got to get the SAM, the system hives, from the image. This is our first little toe into the registry. And then what you do is you use one of two tools. Now, there are plenty of other tools out there, but I like these two, PWDump 7 or Kane. Now, EC Council says Kane because this is about hacking forensics. So therefore, we already have Kane in our tool set, and we're going to use it again here to kind of figure out what somebody did. Now, what you're going to do is you're going to go in and you're going to dump the hashes, and then you're going to take those hash values and compare them to a database of the known values of hashes, and then you're going to get the password for that particular account. This is a long process. And the book that you want to look in is by Carvey. It's on page 96. It talks about all the details of this, how you can do it, why you can do it. It's about 8 or 9 pages. I'm going to point to that book at the end. That's probably your key resource for Windows machines about registry settings, along with another paper that I'll point to. So that's one way to do it. There's a much more clunky way to do this. You can go to pogostick.net/PNH/NT passwords, and there is a gentleman who's done a lot of work on creating basically what boils down to a boot USB or a boot CD that will allow you to go in and reset the password. Now, there have been a lot of attempts to use this tool to reset the password to something, and it doesn't work. But when you use this tool to reset the password to blank, most of the time it works. There's a problem with this, though. If there are any encrypted files, if you're using the native Microsoft encrypted file system, EFS, you will not be able to get into those files. There is no returning to those files, even if you can boot the system. So what I would do from an examiner standpoint is I would step back and say, okay, I know I'm going to have to crack the password on this. What I'm going to do is I'm going to look for the presence of encrypted file systems while it's booted. If I've already been given the machine and it's already shut down and it's never been run before, well, maybe I go ahead and set up, after my reference copy, I go ahead and I boot this machine through a VM, and I boot up into it with my ISO stick stuck in it or my ISO file installed inside of this virtual machine, and I use this tool, this pogo stick, I use this NT password resetter to reset the password to null, and I'm okay. What you have to do is you have to say, what state is the machine in? And the best for password security issues is that it's too late, the machine's already knocked down, and you're just doing it from a dead file. Use that file to then boot and work with that system, not the evidence, copies of. That's password security issues. let's talk a little bit about volatile data overview, what we're going to come into now. You need to know certain artifacts to tie this computer to this particular assailant or adversary. And the data that you're going to use here will establish a lot of ownership here, along with a period of activity over a long period of time. So you're going to collect up this information. It will also lead you to other evidence. In the case of a network share, you want to know that in this home user here, you think, oh, he's just connecting to the internet right here and he's going out. He may have a little tiny file server, like I do in my house, tucked up in the ceiling, hidden away. You don't even see it anywhere. But if you went in and looked at this volatile data, like what the shares were, you could actually see, hey, somewhere else inside of here is another, well, it's a little file server. So we want to collect that volatile data while the machine is running, recording all of our actions so that we can gather more evidence. A lot of people would say, well, don't change the machine at all. Well, no, all I'm doing is I'm viewing all the activity on the machine. I'm typing in those commands, and I know exactly what command I'm typing, and I'm documenting that. So that's not really changing the machine. It's just giving me information about it before I actually shut it down so that I can gather more evidence at the scene. We're going to go into each one of these systems, and we're going to go through a checklist of things that you should be capturing as you're going along in the next step.